Hello again. Welcome to 253 Process Troubleshooting. This is your final lecture, Chapter 6, Absorption and Stripping, Part 3. Yay! Okay, we're going to troubleshoot absorption and stripping process. We have two problems we're going to go over, all right? You do need your schematic on page 6-23, figure 6.1. That'll be helpful. So we'll go over using the troubleshooting tools. We look at material balances, energy balances, interrelationship of variables, what is expected, time factor, process knowledge, and knowledge of heat transfer principles. We collect the data, we evaluate the data, we make the judgment, we develop a possible cause list, we verify the most probable cause, and then we plan and execute a corrective action. Always keeping in mind here the safety issues, the communication issues, and you need to make sure you communicate with everyone, any lockout, tag out if you have to do it, and always documenting what you did so the next person knows what changes were made, always the safety issue. Okay, this is our table that we look at in our sheet. All right, first we need to go to your exercises. Exercise 6.1, there's a couple of errors on the paper, so you should just fix these. Your instrument indication should be 45% and your chart factor should be 110. And then FI58, the chart factor should be 100. So in exercise 6.2, that's the same as 6.1. And LIC55, the controller output should be 62%. And FI57, the current value should be 2900. Then in exercise 3, it's similar. You put the same numbers in that you did for exercise 6.1. Okay, and that's going to be your homework. All right, let's start at exercise 6.1. So if we look at the paper, we see that FIC 50, the indicator is down 3 pounds per hour, and the output is up. It should be 45% and to 100%, so it's up 55%, not 65. FIC 51 is down 835 pounds per hour. The output is at 50% and normally, and is up to 100%, so it's up by 50%. FIC 52, your steam in is consistent, it's normal. PIC 53, which is the vacuum on the S3, it's okay, but the output is up only 5%. PIC 54 is okay, but its output is also up 15%. And then LIC 55 is the level 2 D3, which is your absorber. Okay, that's okay, but its output is down 10%. So it's trying to close and not fill the liquid as much. LIC 56, the stripper, is 50%, 50%, but it is down. It's actually down 5% from 70 to 70. I mean, it's up. I'm sorry, it's down 70% to at 75%. Okay, let's look at FI57. FI57 is down 491 pounds per hour, and it's normally at 70% of indicator, and it's at 75%. That's okay. FI58 is up 500 pounds per hour. It's normally 500, and it's at 1,000. TI59, which is the instrument indicator of temperature in D2, is down 3 degrees. Okay, I'm sorry, it's up 3 degrees. I'm reading these backwards. And then FI60 is reading 4120, that's up 120 pounds per hour. And your LIC 61, which is the decanter, the separator S3 level indicator, is okay, but its output is up 2%. Okay, so let's look at all the information we have here. FIC 50 is a low flow with 100% output, so that's not expected, right? So if you have 100% output, the flow should be really high. It's just low. It's not reading accurately at all. FIC 57 is the flow with FIC 51 flow down, and both of the controller outputs are down. They show low absorbent volume. That's just an interrelationship of variables. PIC 54 and PIC 53 outputs are high, showing a venting of catalyst and not recycling. That's our process knowledge. And then FI 57, the flow is down and the steam is okay, but the temperature is up, so there's an energy imbalance there. And then TI 59, FIC 60, and LIC 61 are all outputs are up. There's more condensables leaving D2 process knowledge, okay? So if you look at the information here, one of the things we need to see is what is the real issue around it. It seems as if the absorber column is really out of whack. So we have to figure out, is it before the absorber column making the absorber column go out of whack, or is something in the absorber column which then affects all of the downstream process variables, and all the other process variables downstream of the absorber are actually reacting as, again, interrelationship of variables and what's expected. So I believe that it's somehow connected to the absorber column and something before that. So we're going to look at this part because I do think this is a big issue here. Okay, so we have a problem. We're venting catalysts and we have a high temperature, and multiple low absorbent flows indicate a shortage of the absorbent material. Low volume of absorbent is causing some catalyst to pass through to the vent, and then the absorbent makeup is wide open and cannot keep the flow up to normal. The blowdown valve is wide open and showing low flow. So is LIC 55 indication an error, holding up material in D3? That's our absorber. Is FIC 50 blowdown flow actually wide open, robbing the system of the absorbent? And then could there be a leak in E7 causing the loss of the rich absorbent? Okay. All right, let's talk about what's most probable. LIC 55 error does not account for FIC 50 output at 100% with a low flow. So that doesn't really make sense. The E7 leak does not explain FIC 50% output at 100% with a low flow. But FIC 50 flow error, we think that there might be an error with FIC 50. It's robbing the system of absorbent, so much so that FIC 51 cannot make up enough of the absorbent. Okay? So let's talk about the verify and plan corrective action. Visually check FIC 50 valve position. Check decanter system for excess flows. Sample the blowdown for water concentration. It should be low due to the excessive blowdown. Set FIC 50 at normal controller output while ignoring the flow indication. It should bring the flow back to normal to close normal. Call for indicator repairs, so transmitter repairs. So the key to solving this problem is recognizing that the loss of the absorbent and a controller that is at 100% output and indicates a low flow. So this doesn't make sense. So the transmitter really has to probably be the main reason that's the problem here. Okay. So go over this again. I recommend, again, before you start the next 6.2, before we do 6.2 here, that you look at it and evaluate what you think might be the problem, and then then you can go over the solutions. Okay, exercise 6.2. Okay, that's on it's in your textbook again. So your FIC 50 is your normal flow. Okay, that's normal. Everything there looks normal. The D2 bottoms blowdown seems okay. FIC 51, that flow seems okay, the lean absorbent flow for D3 into the absorber column, and the output but the output's at 0% when it's supposed to be at 50%, so that's off, it's closed. FIC 52 steam input's okay. PIC, the pressure, the vacuum is okay, but the output is up 25%. And PIC 54 is okay, but the output is also up 5%. And PIC 54 is your D3 pressure control, the controller for the for the absorber column. And then LIC 55 is okay, the level for the D3 column, which is your absorber, but its output is up 2%. And then LIC 56, which is the level controller for D2, the stripper, is normal, but its output is also up 2%. Then FI 57 is up 259 pounds per hour, or I have 329 pounds per hour. I'm sorry, there must be a typo in there. And that is FI 57 is your rich absorbent flow to D2, okay, for the strippers, where it's going into the stripper. And then FI 58 is down to 0. FI 58 is your absorbent makeup flow, so there's a problem there. TI 59 is down, which is your indicator of your stripper temperature, 2 degrees. FI 60 is the makeup, the condensate, S3, the condensate to going to the decanter and joining the blowdown line. That is down 80 pounds per hour. And then the level controller for the separator, that's to the decanter. The separator, S3 level, is okay, but its output is down 2%, which would make this go down. So that's kind of what expected there. So let's talk about what the problems are. Now, Fi58, which is again your absorbent makeup flow, is reading 0 and the output is 0, so that makes sense. Fi57, which is your flow, your rich absorbent flow to D2, is increased with no flow at Fi58. That is not what is expected, and so that is not a good material balance. PIC54 and PIC53 indicate venting catalysts, so that's our process knowledge. And then FIC51 is normal flow with venting catalyst. That's not what's expected. Okay. So 51 too would the lean absorbent flow should be different because we're expecting again, so the balance is out. Okay, we have a problem. We appear to be venting catalyst. The absorber factors appear satisfied. The stripper factors do appear satisfied, although the temperature is slightly low, and that would indicate a high flow of cool, rich absorbent. FIC51 flow indicates normal without any makeup absorbent, and the absorber, not material balanced, output is up, while the venting the catalyst, which reduces the volume. Okay, so this again isn't, the absorber material balance isn't making any sense. So let's find out what we think might be the problem. FIC51, which is your lean D3, the absorber's lean absorbent flow, is maybe there's a measurement error shutting off of the makeup flow. E7, which is your heat exchanger, okay, where it chills the rich absorbent flow, could be leaking material into the system. And then E6 could also have a leak, adding chilled water to the system. Replacing the absorbent makeup, water will not absorb the catalyst. Okay, so that's another key piece there. All right, what is the most probable cause? Now, FIC51 error is not probable because LIC55, FI57, so LIC55 is your D3 level control, FI57 is the rich absorbent flow to D2, and LIC56, which is level in the stripper, indicate that FIC51 is satisfied. So FIC51, the lean absorbent flow to D3, it all makes sense, okay, that number is what it is. E7, though, the leak is not probable because a leak at this point would pull liquid out of the system that would show up at S3, causing more flow at Fi60, which we don't have. We have a lower flow there. E6 leak is probable, and this is most probable because water will not absorb the catalyst, right? But it'll add volume to the system. So then, as it's adding volume, it'll cause the absorbent makeup to shut off at FIC51. So that makes sense. Okay, so FI58 absorbent makeup flow, which is 0, will drop off because you're adding, because it's coming in that particular place. It's almost like a makeup flow there, but it's not the right material. Okay, so this is more than likely the problem. All right, corrective action. Sample your absorbent for excess water content and chilled water treatment chemicals. Throttle down the chilled water input to E6 to balance the shell and tube side pressures to reduce the leak. Report the leak so shutdown can begin. The key to solving this problem is the material balance. The absorbent flow is normal without any makeup. So that tells you you're getting something somewhere coming into the system somewhere. The absorber factors are satisfied, but absorption of the catalyst vapors is less than expected. This indicates foreign material replacing the absorbent. Okay, if you can't pull off, if the catalyst will be soluble in the absorbent, but in this particular instance we're not getting as much catalyst so that means that there is foreign material in the absorbent. Okay, so just try to go through that again and see if you understand that. All right, now you have one more exercise, 6.3. Work on that. And if you need any help with that, let me know. And then you'll have test 5, and I'll open that up tonight so people can get started on that right away. All right. I might just open it up for tomorrow. All right. So just go through this and make sure you understand it, and then use your notes, and hopefully you'll do all right. And this will be the last test is this test, and it's due next week. Okay. So then you're done with this class. All right, you guys. You have a good night, and I'll talk to you soon.